So we have started with DC network theorems. The last theorem remaining in this topic and the module as such is not module, the part 1.1 of the module as such is maximum power transfer theorem. So we have just a formula maximum power transfer as P max equal to VTH square upon 4 RTH. So what is the thing? We have to find RTH. So for RTH, if we are using dependent source, what is the formula? RTH is VTH upon IN. So we have to find VTH and IN if it is a dependent source. If it is a independent source, we just have to find VTH and RTH, right? So we have already done this using Thevenin's and Norton's theorem. So I'll directly start this. I will not give you the steps. So for that you can see the previous videos. So find the value of RL for maximum power transfer and find maximum power. So this is RL, the value which we have to find. So from maximum power it is known that it is RTH equal to RL. So for that we have to find RTH and we also have to find the maximum power, right? So what is the first step? It is the calculation of VTH. So we remove the load, place a open circuit across it and find the open circuit voltage which is called as VTH. So let's redraw the diagram. So here we have plus minus VTH. This is 3 volts. This is 2 ohms, 2 ohms, 6 volts, 2 ohms, 10 volts. Right? So now this is open circuit, so no current will flow here. So current will only flow through this loop. Let's say it is I. So what will be the total current? We can directly write by Ohm's law. So I will be 3 minus 6. So minus 3 upon 2 plus 2 which is 4. So I equal to, if I want to take plus 5 plus sign, it will be 0.75 ampere. Direction will be anti-clockwise. Right? So now I have to find VTH. Right? So how to find VTH? I can take this outermost path. But I'll have to take this also because there is a 2 ohms here. Otherwise, you can take this path. Right? So 3 minus 2I minus VTH minus 10 minus 2I equal to 0. Now I am taking clockwise direction. So current I have taken clockwise. So this is for anti-clockwise. So for clockwise it is minus 0.75 ampere. So I'll use 3 minus 2 into minus 0.75 minus VTH minus 10 minus 2 into minus 0.75 equal to 0. So let's find VTH. So VTH will go here, it will be plus. So 3 minus 2 into minus 0.75 minus 2 into minus 0.75. 6. So VTH equal to 6 volts. Right? Next, what we have to find? We have to find RTH. So second RTH. So it is an independent source. So we remove all the sources. Voltage sources are shorted. If there are current sources, they will be open circuited. Right? So 2 I can directly say from here only. So again I remove the load. So instead of VTH I can write RTH. So this will be shorted. So 2 and 2 will be in parallel. So better I'll draw it. So RTH I am finding here. This is 2 ohms. All are 2 ohms. So how will you calculate RTH? You can see these 2 ohms, these 2 ohms terminals, this is the common point and this is the other common point for the other terminals. So these two are in parallel. So parallel 2 and 2 parallel same value. So half of the value will be 1 ohms. So 1 ohms we can easily see this will be in series with 2 ohms. So it is fine if you directly write the answer in this case. So RTH equal to 3 ohms, right? So what is, then what we will say? You want to find RL, that is the question. So what we will say? By maximum power transfer theorem, maximum power is delivered to the load when RTH equal to RL. So therefore, what is RL? It is equal to RTH. So RL equal to 3 ohms. Next, they have asked calculate maximum power also. So what is it? VTH square upon 4 RTH or 4 RL. So VTH we know it is 6. Yes, it is 6. So 6 square divided by 4 into RTH, which is 3. So 3. So power maximum is 3 volts. Right? So this is the way we have to solve sums on maximum power. So let's take a next sum. So the question is, for the network shown, find RL for maximum power transfer and calculate maximum power. Okay. So what we'll do, this is RL. So again we'll open it. So first step is VTH. So this will be what? VTH. So this is 50 volts. This is 40 ohms. This is 20 ohms. This is 10I. And we have, what is the difference? We have a dependent source. So we have a dependent variable I. Right? Now you observe these were two meshes here. Now we have only one mesh because this is open. So again we'll have a single current. And can I say that current will be equal to I? So I'll directly take I. Right? So I'll apply KVL to the outermost loop. What will we get? 10I minus 20I minus 40I minus 50 equal to 0. So therefore 10 minus 20 minus 10 minus 50. So minus 50I minus 50 equal to 0. So I equal to minus 1 ampere when considered clockwise. Right? What do you have to find? VTH. So let's take which path we'll take. We'll take this path. If you want again, you can take any which path you can. So VTH minus 40I in clockwise direction, remember, minus 50 equal to 0. So therefore VTH equal to 40I plus 50. And we have taken I in clockwise like this. So I will be minus 1. Right? So 40 into minus 1 plus 50. So VTH is 10 volts. Next, what we have to find? RTH. But we have a dependent source here as opposed to the previous sum which had a independent source. So what will we do? Instead of opening it, we'll remove the load and short it. Rest all will be same. And we'll have a dependent source also. So this is 40 ohms, this is 50 volts, this is 10I, this was that I, this is 20 ohms if I am not wrong. So 20, 40, yeah. Next, what will we do? We'll say this is I1, this is I2, and this is IN we have to find. So dependent variable first we'll write, what is it? I2 equal to I, first equation for dependent variable. Right? Then you will apply KVL to this loop and this loop. Right? So 10I minus 20I1 equal to 0. And I is I2. So therefore, I am writing I1 first. Minus 20I1, I is I2. So plus 10I2 equal to 0. Equation number 2. Then this loop. So minus 40I2 minus 50. So minus 40I2 minus 50 equal to 0. So therefore 40I2 equal to minus 50. So therefore I2 equal to minus 5 by 4. I think it is 1.25. 5 divided by 4. So 1.25. It is minus. So minus 1.25 ampere in clockwise direction. So here we have taken I2 as clockwise direction only. So minus 20I1 plus 10 into minus 1.25 equal to 0. So therefore 20I1 equal to minus 12.5. So minus 12.5 divided by 20 minus 0.625. So I1 equal to minus 0.625 amperes minus. This is in clockwise direction. right? This is I1, this is I2. So ion will be what? It is I1 and ion are in same direction. So I1 minus I2, considering both are clockwise. So both we should take as negative only. So therefore ion equal to minus 0.625 minus of minus 1.25. So 1.25 minus 0.625. So 0.625. So therefore ion equal to 0.625 amperes downward direction. Ion is downwards. Right? So what will be RTH? So RTH equal to VTH upon ion. VTH was 10 volts. So therefore RTH equal to ion is 0.625. So 10 divided by 0.625. So 16 ohms. Again remember RTH can come out to be negative. In this case it is positive. So again we'll say by maximum power transfer theorem, maximum power is delivered from source to the load when RTH equal to RL. So RTH equal to RL equal to 16 ohms. So this is the value of RL. And maximum power is delivered when Pmax equal to VTH square upon 4 RTH. You have to write the formula. It carries marks. So Pmax equal to, so VTH was 10. So 10 square divided by 4 into 16. So 1.5625. So 1.5625 watts. So this is the final answer. Right? So let's take one more sum. And next week we'll be having a tutorial. I have not mentioned this, but you have tutorials also as you have for mathematics. So we'll have a live tutorial most probably. I'll see what the logistics and I'll let you know by tomorrow or day after. So next question is, for the network shown, find RL for maximum power transfer and also find maximum power. So where is the dependent source? This is the dependent source. It is the variable is Vx. So this is Vx. So what we have to find first? RL for maximum power. Where is RL? This is RL. So let's redraw the network for VTH. So plus minus, this is 1 ohms, current source 1 ampere, voltage source, this will be open. This is VTH. This is 2 volts, 1 ohms plus minus Vx, 2 Vx, 1 ohms, 1 ampere. Am I correct? Yes. So again, this is open, so we have only one current. Let's say it is I1. Before this, we'll write the equation for dependent variable, right? So current is flowing like this towards right for Vx. So this is plus, this is minus. So opposite sign, so we'll include a negative sign. So Vx is I into R. So I1 into 1 and minus sign. So minus I1. This is the first equation corresponding to dependent variable, right? Then what will be I1? It will be just minus 1 amperes because this is open. So no current is flowing here. So I1 equal to minus 1 ampere. Equation number 2. So what we have to find? VTH. So what will we do? We cannot take this path. So we will take this path. Because here is a current source, we cannot take this path. So VTH minus 2. Now what is happening here? Current is going plus to minus in this direction, but we are going in opposite direction. So it will be plus I1, remember, for clockwise direction only, minus 2Vx equal to 0. So therefore VTH minus 2 plus minus I1 minus 2 into Vx is minus I1. So plus 1 equal to 0. So therefore I1 is minus 1. So here it will be minus 1. So VTH minus 2 minus 1 minus 2 equal to 0. So minus 3 minus 5. VTH equal to 5 volts. Right? Next, what we have to find? RTH. So we'll short this and find I. shorted. This is to be find out IN 2 volts 1 ohms, 2 volts 1 ohms, plus minus in this direction Vx, this is 1 ampere, this is 1 ohms, this is 2 Vx, right? So what we have to do again, mesh analysis, right? So I will not solve this, I will give this as homework. So what we'll do, I'll just tell you the steps. So again I1, I2, solve using mesh analysis, then I2 will be equal to IN, then RTH will be what? VTH by IN. So you'll find RTH, then you'll say by maximum power transfer theorem RTH equal to RL, and finally you will find Pmax, VTH square upon 4 RTH. Okay, so make sure you solve this.